gold beneficiation. Okay, so we can get started with part 1. So in this session, we will be looking at the factors that need to be considered from a technical perspective when selecting a processing route for your operation. Okay, but I'm going to start off first with a bit of background on the gold metal itself, just sort of going through its properties and characteristics as to why we like it so much. So the first reason is that it is visually attractive. It is appealing. It is nice to look at. It is shiny. So for that reason, we really like it. Secondly, in nature, gold is quite rare, and it has average concentrations of around 0.05 grams a ton. So this means that you need to then process a lot of ore in order to extract a small concentration of gold. It is soft and malleable, meaning that it can be molded easily when it is pressed. It is ductile, meaning that it can withstand high amounts of stress while still maintaining its strength. It is also a good conductor of electricity and heat. Gold is also a noble metal, meaning that it is unreactive in water. It is unreactive in alkaline solutions and in almost all of the acids that are known. It is also corrosion resistant, and it can naturally be found as pure gold in nature. So the uses that we use it for typically, we make jewelry out of it. We also use it to make coins, and we also use it in electronics. So just a brief history on the mining of gold. So if we look back in time, we can see that gold has been a highly valued metal for a very, very long time. So there have been objects that have been found in Egypt, in Greece, all over the world. Some of them that date back to before around 5000 BC. And that is quite a long time ago. But ancient gold production is credited to the ancient Egyptians, who started alluvial gold mining around 3000 BC. So by around 2450 BC, they had also established some underground mining operations as well. And then later on, we see then gold mining sort of spreading to other parts of the world, even going to the Iberian Peninsula around Spain and the Portugal area. So later on, between the 7th and the 13th century, we know that gold was traded between African and Arab traders, and this gold was sourced from the alluvial gold deposits in the Ghana Empire of West Africa. Okay, then by the 14th century, the Mali Empire continued then mining from the Akan and the Asante deposits. And then from around the 15th century, that's when we now see gold mines also established in the Americas after it was discovered by the likes of Christopher Columbus. Then around the 17th century, that's when we now see a great boom and global gold production just sort of taking off. And from that point on, there was a lot of gold deposits that were then discovered around the world. So in Canada, in the USA, New Zealand, Australia, also including the Greenstone Belt, which was discovered around Tanzania and Uganda, and the Witwatersrand deposit that was discovered in South Africa. So even today, we still have a lot of gold deposits that are being discovered, such as the 31 million ton deposit that was recently discovered in Uganda. So this just shows us that the topic of gold beneficiation is still a relevant one for us to be talking about today. Hence, sessions like this that are quite helpful for us. Okay, so I'm going to get straight into the factors that one needs to consider when selecting a processing route for gold-bearing ore. So these are typically categorized into geological factors, mineralogical factors, mining, metallurgical, environmental, geographical, political, and economic. So I'm going to go into each one of them in the following slides. All right, starting off with geology. So the geological factors include firstly establishing the grade and the reserve tonnages of the ore. So this helps with then determining the level of investment that you're going to be making into processing the ore. So if the ore is low grade, then you would sort of consider your low cost processing options, such as heap leaching. But if it is a high grade ore, then you can rationalize using higher cost processing methods, such as maybe having a CIL circuit and possibly some sort of pre-treatment stage in there so you can optimize your recovery. Similarly, you would make a higher investment if your deposit has higher ore reserve tonnages. And this is for business longevity, so you can keep processing over a longer period of time. Okay, then getting to the ore body geometry, this has to do with the shape and the spatial arrangement of the gold-rich ore. And this will have an impact on the mining method that you select and the mining sequence. So the shape of the ore body can affect essentially how much gangue material is transferred to the plant along with the gold from the reef belt. Then the last point there, ore property variations. This refers to differences in the minerals and the rock properties across the entire gold ore body. So for example, properties such as the hardness and the composition of the minerals within the ore. These will not be the same across the entire ore body. So the processing plant must be robust enough to weather these variations. Okay, moving on to the mineralogical factors. These include the ore composition and physical properties of minerals. So at this stage, your gold-bearing minerals and gangue minerals are identified, as well as the properties of the host rock. So these results help with establishing whether your gold ore is free milling, whether it is complex or refractory, and to what extent that it is refractory. So the processing plant for free milling ore is much simpler than that for complex and for refractory ores. So once you find out that your ore is complex or refractory, that gives you an idea that you are going to need then additional steps in your process to improve your recovery. Then the physical and textural properties of the rock are essential when exploring ore dressing options for the plant. And this is to ensure that you get the most optimal liberation of your gold minerals. Okay, then the mining factors. These include the mining method that you adopt, the blast design, the mining mix, and selectivity. So the mining method and blast design have an impact on the ore fragmentation that will be sent to the plant. That is basically your distribution of your coarse rocks, fine rocks, that is then sent to the plant. And this will then influence the plant ore dressing options and the manner in which your comminution equipment is operated. Then the mining mix and the mining selectivity, these influence the composition of the plant feed. So for example, there may be instances where there is more than one type of gold reef in an ore body, and these have different characteristics. So the mining team that is then, blasting and sending the material to the plant, they can either decide to mine everything at once and send all of it to the plant, or they can selectively mine one type of reef over another. And maybe in certain ratios, then create a blend of material that is then sent to the plant. So this then has an impact on the composition of the feed to the plant. Okay, on to the metallurgical factors, and these include the recovery, the product specifications, the plant capacity, the capital and operational costs, the technology test results, and the outcome of a techno-economic assessment. So with regards to the metallurgical factors, the results of a gold deportment study are essential. So basically a gold deportment study is a full mineralogy analysis of the ore. So this study will sort of inform the types of technologies and the processes that are to be selected. And whatever process or technology that you use is going to have an influence on your gold recovery. And that is obviously then linked to the revenue that you're going to generate. So a techno-economic assessment, which is essentially a trade-off study, this must be done in order to evaluate the feasibility of a processing operation. So during this techno-economic assessment, other factors then are also considered, such as the environmental impact of the processes and perhaps any permitting requirements that are needed for your process. Okay, under environmental, the impact of the selected processes on the surrounding environment is considered. It is at this point where measures must be in place to comply with environmental legislation. So the selected process flow sheet must include a waste treatment and disposal plan. And this must highlight the volumes of waste, the method of disposal, plans for reclamation, a process water balance, and waste treatment methods, if those are applicable to your process. And this is essential because as gold processing plants typically use hazardous chemicals such as cyanide, they use hydrochloric acid, just to name a few of the chemicals that are used. And these pose a threat to the environment and even to the people that are living in the community. So there needs to be an effective means of containing the risks that they pose to the environment. Okay, then the geographical factors refer to location-specific factors that need to be considered, such as the climate of the area, water availability, the availability of labor, communications, infrastructure, the proximity of the plant to suppliers and to maybe your distribution harbors, etc., etc. The list goes on. So these factors then have an impact on the cost, and they vary from one geographical area to another. Then you've also got your political and economic factors that need to be considered, as these can affect then the viability of the process operation. However, the thing that needs to be considered then is that these factors are quite volatile, and they cannot really be controlled by anyone in the business, as they change over time, and also with where your business is located as well. However, you just need to have some sort of risk factor that is applied to consider these changes. Okay, so in summary, I'm already giving the key takeaways for this webinar. The thing that you need to keep in mind when you are designing a plant is that each gold ore deposit, so there must be a thorough understanding of the ore mineralogy in terms of the characteristics of the gold minerals, the gangue minerals, and the properties of the host rock as well. So a good place to start when you are selecting a processing route is to carry out a gold deportment study, and this is to establish the gold minerals that you have within your ore body, which will give you then an idea as to which processes are suitable. The gold deportment study also has the added benefit of establishing the acceptable tailings grade and identifying the species that can affect your gold recovery. Okay, so on this slide, I've got a summary of the types of gold minerals that can be found in different modes of occurrence So that can be as microscopic gold, as submicroscopic gold, and surface bound gold. I'm not really going to go into this long list, but during the ore mineralogy phase of your study, this is the types of minerals that you might encounter. Okay, so then this slide gives a breakdown of the microscopic gold minerals, showing the common gold minerals such as native gold, which is typically found as alluvial gold. There are also some gold alloys, such as those associated with PGM deposits, and gold amalgams from tectonic formations. Okay, so as previously stated, a gold deportment study is crucial for process selection. So the flow sheet on the left gives a summary of the gold deportment methodology, where each form of gold is analyzed for. By form of gold, I'm talking about microscopic gold, submicroscopic gold. They go into each of those different forms and identify the minerals associated with those. So the analysis includes your head gold analysis. A bulk modal analysis is also done to determine the composition of the ore. Next, it will include some sort of sizing analysis, where each size fraction is assayed to determine the distribution of coarse and fine-grained gold particles. Lastly, then, the recovery is estimated, and this is done by running gravity, flotation, and cyanidation test works. So the recovery that is then determined, if it is above 90%, then it is indicative of a high-grade free milling ore. But if the recovery is less than or equal to 80%, then the ore is more complex and requires more test work that simulates oxidative pretreatment processes in order to improve your plant recovery. Okay, so this slide just reiterates the full characterization test work, which needs to include your mineralogy tests, your ore textural tests, as well as metallurgical tests to get a full picture of the ore that is going to be treated within the plant. Also, to improve the performance of your operation, the data that you generate from your test work can be incorporated into a geometallurgical model. So this geometallurgical model rather, will consider the nature and characteristics of the ore, among other factors. And this is done to then predict your product volumes and qualities. Okay, the gold ore types. So gold ore is typically classified as free milling, complex, or refractory. So your free milling ores consist of oxides and your non-refractory sulfides. Then your complex and refractory ores contain varying compositions of auriferous base metals, and they also may be robbing as well. So on the right, I'm showing a diagram that basically ranks the different types of gold ores in the order of increase in refractoriness from top to bottom. So we can see that placers and the quartz vein ores are less refractory, they're more free milling. Then your most refractory ore is your carbonaceous sulfide ores. Okay, so for free milling ores, the typical processing methods applied are comminution, gravity concentration, flotation, leaching, and then some sort of concentration or purification stage, followed by recovery and finally the refining of your gold. Okay, then for complex and refractory ores, they require some